this is a new experience. Welcome to my stream. I'm going to be doing some Proc-Gen building using the Apparance plugin. First time stream. I wanted to make sure things are working. So first, assuming everyone can hear me. And standard. That came through. Okay, go with that for now. So, what is Apparance? That's probably a good thing to start with. And who am I as well? I'm Sam Swain. I'm a creator of a plugin called Apparance, and it's available for Unreal and Unity, and it's for building procedural systems. And the trailer you saw in the intro showed some of the things we've built with it. We do client work, we do prototypes, we do our own demos and things like that as well. It's been in development for quite some time. In excess of 10 years I've been working on it. And I thought it'd be good to show some actual use of the tool firsthand from me. And as a test case, we're just going to start simple. I'm going to play with some assets, an asset pack I bought. I can show you the asset pack. So it's fairly straightforward. Space station kit. We'll probably start with some of the wall pieces first, and then we'll do things like floor and corners, and as we progress, we'll see how we get on today. I'm intending on streaming about an hour. If it goes well, I might do a bit longer. If it all goes horribly wrong, it'll be shorter, but we'll see how it goes. So this is a kind of example of a piece made out of those assets. A bit of floor, walls, and ceiling. There is a demo scene which is probably worth showing. Demo map, yeah. This comes with the asset pack. Pages are loaded and shows you the sort of things you're supposed to be able to build with it. All very nice. There are different materials, skins, I think, different colours. I'm not sure if we'll get onto that today, but the vanilla one looks like this. You can see that all the pieces can be snapped into the scene. Thank you, Lara the dev. Wish me luck. Yeah, so lots of pieces. They snap together in all sorts of different ways, and we'll see what we can do. I think to start with, we'll probably be working with, as I said, these wall pieces. There's like this wall piece here. The top and bottom piece go with it. Yeah, we're going to start basic and build up. And I'm going to try and assume no previous knowledge of Apparance, which is fair, I guess. If there's any questions. Okay. Is that any better? I can probably move a bit closer as well. How about that? Let's go with that. I should be able to boost it a bit as well if needed. Let's try that. So let us see. Right, I'll go back to my map, which I created. Better, thank you. Yeah. I probably will be mumbling at various stages and talking to myself, so please excuse those moments. I will try and do my best to speak up. Right. So, Apparance is a procedural tool for building geometry and placing objects, basically. And it centers around a thing called a particular actor called the Apparance entity. And then initially, obviously, that doesn't have anything attached to it. There's no procedure set. We can see the Apparance window over here. I'll open the Apparance editor. Let's do that. So this is the Apparance editor. It's a separate application, runs for building your procedures, and it connects to the running instance. I think I might be in the way. Right. I'll move it over a bit. There you go. So initially you don't really start with any procedures, but I've put in some utility ones just to get us going, and I will use those to start with. So if I just create a new procedure, I'm going to call it new category test, and it's going to be a piece of actually it's just a test, so we'll do that. This and this is what an empty procedure looks like. We've got inputs on the left, outputs on the right, and all the operations and other sub procedures go in the middle. So to illustrate a little bit of that, I've got this procedure I prepared earlier called show box, which is purely, if I wire it up, give it a little bit of color, it's purely just going to draw a box, and if we set our procedure to that, we get the green box. And then there's a default, this input here, bounds, appears as one of the input parameters you can tweak here. So if I change the size of the box, the frame bounds, it rebuilds it to fit that. And this is now just an actor I can position in the world. Let's be neat and put it at the origin. Okay, so if I go back here, so that was just a box that can be useful for debugging and showing where things are as you're building your procedures. There's another one here called show frame, which is a bit more advanced, and if I wire that up instead, you'll see that draws a sort of more bounds-like representation of the space that it's been assigned. Plus, it also shows you the axes of the frame. Apparance's coordinate system is more like CAD and has a X to the right, Y forward, and Z up, which you can see is slightly different to the Unreal axes. But again, if I change the X, that gets bigger, the Y, that gets bigger, and the Z, that gets bigger. The frame drawing logic has some bits in it to make it sensible thickness, just so it's a bit more usable. We'll probably use this quite a bit because it's very handy for, as I said, seeing what's what in your procedures. Right, so the next thing is to start looking at the assets. Assets are referenced using things called a resource list, which is basically a mapping from a name to an asset in Unreal. I've set this one up, this list up already. We can see here it's got some, it's basically empty. So I'm going to add a resource in here, which I will call, we're just going to, let's call it a wall, because I'm going to put a wall piece in there. We're going to dig in into the asset pack we're looking at. I think the wall piece, there aren't many bits of variety in here, but this is fine for what we're doing today. I'm just going to drop the wall piece in there. If we can have a closer look at that while we're at it. So this is the wall piece that came with the asset pack. I think it's all aligned. I can't remember where it's aligned, but that shouldn't actually matter. And it's, yeah, so that's what we're going to start with. We've put it in here. It's under the root is called station, which I've made match the name of the resource list. Then I've given it a name. And that gives it a descriptor, which here is station.wall. If I copy that, we'll need that in a minute. Save that. And if I go back to procedure editor, we can see here, I might move me over a little bit. I'm a bit intrusive. There we go. So this time I'm going to set up a new procedure, and I'm going to call it wall. So we're going to have a category called wall for all the wall related procedures. and this is going to be a piece of wall. Let's open that. Now we search for resources. So this list here at the bottom left is the list of all the fundamental operations you can do in procedures. It's quite a large collection of categories, and within each category there's a load of actual procedures you can use. I think there's also, I'm going to turn on the experimental category or filter, which brings in a few extra ones that we might need, but not right away. So I'll leave that on. And if I just search for resources, under here we've got a few things that we'll need, particularly the resolve, which turns a descriptor, which we can put our station wall in, and then we get an ID out and some other information about that asset. I will then also need place, which is how you put them in the scene. Let's take this back down again. Right, so if I give that, plug that ID in there, bring the bounds for where we're placing it out here. These white wires are basically content. They have a couple of different terms. We'll come to that in a minute. But anything in these white wires that collects together and is fed out to the final output is what you see in your scene for that actor. So that's basically that setup, and we can try that. So what we'll do is just use the same actor, but I'll set it here to wall piece, and lo and behold, a very distorted piece of wall for very good reasons. So if let's set this thickness down a bit. Yes, it's aligned in the the Unreal y-axis, which is the Apparance x-axis, and that's where the thickness has to be applied. At the moment, it just follows the bounds of the space we're asking it to place in. But we can do better than that. So let's go with this. What we can do, this bounds information that comes in is from the original asset, and so that can be extracted. If I go to the frame operators, there is a dimensions, which if I wire up to there, gives us the size in each axis. And if I use something called split, which is basically takes a frame and splits it into two pieces, which, whilst we're not using both pieces, it's a quick way of just resizing in one axis. So we'll feed that in. We want the X width there. We're going to be in units, not proportion, and we're in the X-axis. That's fine. And then the main frame output is the first bit of the split, the lower side. So I feed that in there. Now we have it being the actual thickness. I think it looks a bit fat because this is actually smaller than the asset we were using. Which if I go back to here, we can see that looks like it. Yeah, the default size is like 4 meters by perhaps 2. Yeah, so let's go with that. And if I just set our size here to 4 and 2, that'll look much more like the actual asset. And now if we specify the thickness, it ignores that and uses the asset thickness. So that's our first step. Placing down a piece of wall. I think, goodness, that took 15 minutes. I think I'm planning to stream for an hour. If it goes well or there's making good progress, I might carry on for a bit longer. Feel free to drop in and drop out. That's all good. And any questions along the way, fire up the chat window with those, and I'll see what I can do. So next thing to look at is going to be placing these in a row, so we can have a length of our space station and have the walls built in a line. So what we'll do for that is, now there's different ways of doing this, but what I'm going to do is create a new procedure, and it's going to be wall row of all pieces. And we're going to start with a very simple way of basically what is filling a space or iterating. And we can reuse this bit of functionality in a minute to place the actual wall. We don't have to do that again. So if we've got a space, let's say we wanted where's it going to be? So the y-axis, if we wanted 3 pieces of wall, that'd be like 12. At the moment, obviously that'll stretch 1 piece because that's that procedure. If we switch to our, we'll come back to that, but we will start building this. What we can do is again take the split, which for now we'll just go right. We're going to take 4 meters off the y direction because that's the way the walls are built, and we're going to use that to place a piece of wall. Right, that's the first step. Update our procedure to point at the row. There we go. So now we have that first 4 meters is a piece of wall. So the next bit gets a bit funky because what we can do with this remainder, the rest of the wall, we can feed into this procedure. So if I take another row, so this is the same procedure, I fed it in. This is what's known as recursion. So this will be going in and in and in and in until it stops for some reason. Well, we'll see what happens in a minute. Because we've now got 2 things that we want to show, we need to combine those together or merge them. At the moment, there's a variety of merge operations because based on the number of inputs, but that'll be improved in the future version. So if we connect up that one and our row and connect that, we will get a row of walls. Unfortunately, it goes off to kind of infinity. Yeah, it effectively does. It doesn't actually go to infinity. There is a limit to how many iterations you can do in a procedure, but all that's configurable. The problem being, we need to say, oops, hang on, we need to find a way of telling it to stop. So the simplest way there is to find out how much space we've been given to put the wall in, and if it's less than a piece of wall, then don't place something, and that will be our exit condition from the recursion. So let's do some calculations to work out that. First, we need the size of the space we're filling, so get the dimensions of this frame. We're building in the y direction, as we saw here, so I'm going to check to see if the y is greater than, let's say, 4 meters, because that's our minimum size. We need at least 4 meters to put a piece of wall down. Now we can do some conditional things. Now it's called if seg, but it's basically there's the content wiring, or the way of switching the content. Bit of background. It's based on the term modeling segment, which is internally what these white wires are called. Again, that's probably going to change in the future. But what you need to know is the if seg is how you switch content. So what we're saying is if there isn't 4 meters, we won't do anything. So I'll leave the false disconnected. But if there is 4 meters, we will return some output. Now, what's going on here? We've got 2 pieces of wall, and we haven't quite filled that space, which probably should fit a wall. So what's going on there? I think it's probably because when you're comparing floating point values, it's very fussy and needs, and it's very easy for tiny little inaccuracies of the calculations to creep in. So what's probably coming through when it gets to this third space is it's getting slightly less than 4, which is a little bit annoying. But for now, we're keeping it simple. We're just going to do a simple fix, which is make that slightly less than 4, and now it'll get a value probably a bit bigger than that, just shy of 4, and now that'll be true on that last segment, and we can have all 3 pieces. So what that means is we now have a procedure for the wall where if we change the length and if there's room, it will keep adding pieces of wall. So that's how we get our length of wall. As I mentioned, there are other techniques for building pieces like this, but this is going to be the simplest way of doing it. I might label this as I normally label this to show that that's where we're recursing, and it's using recursion as a technique for iterating. So we do all this logic multiple times until we are no longer we disable the recursion, and then it stops, and then it bubbles all the way back up, gathering all the pieces that you've placed, and that's your output. Okay. All good. Next, I think what I'm going to do is I'll just save this level and go back to the look at the asset map. So back here we can see what we need to look at next. I think what I'll do, we could put the window in. The window would substitute nicely, I expect, because it looks like it's the same size, and we could introduce a few more concepts, or we could look at trying to assemble this top and bottom piece. I think I might do that next, because there's this piece here which integrates the floor in, and then there's an angled piece to integrate the ceiling. I think they're probably different sizes, so that'll add an interesting challenge to everything. So that's wall A2 and that's wall C2. That's D2. Okay. I'm guessing it might be to do with their size. 2 units, perhaps. Yeah, because these floor pieces are. Oh, maybe not. Right. Let's get these wall top and bottom pieces in. So we need to be able to refer to them. So we're going to add in a couple more resources here. Let's call it wall top, and we'll call this bottom. And they are. Is it that one? Oh yeah, there we go. Wall A it's called, and that one's called wall C. Wall A is the bottom, drop that in there. Wall B, no. Wall C is the top. Okay. Again, they have their descriptors. Let's start with the bottom one. And I will have a look at that. Let's go back to our map here. I'm going to start a new procedure because now the wall's getting a bit more complicated. Let's do one called section. Let's call it that. Floor to ceiling wall section. Always good to keep things described, and then if you place a procedure down, you'll get that description as its tooltip. So the wall section, it's going to kind of replace the piece in this row. So we can instead of placing a piece, we can place a section, and then we will get them all in a line. We've already done that logic. So it's going to be a single width, which we know. So we'll just follow the size we're given. But we need to split it vertically into the bottom, middle, and top, which for now I think we're going to assume is fixed size. So we'll do that first. Again, we can use some frame operations. The frame type is, if it hasn't already been obvious, is a kind of oriented box in space with a size, an origin, and an orientation. And they're really useful for building things because you can start with your whole structure and its bounds, and then divide that up into pieces, and then start populating those pieces using different procedures. So the section is going to have vertical pieces split off. What we'll use the split again because we're doing single divisions, but this time we're going vertically, which is Z for apparance. I think it's 2 units high, so we'll just put that in like that for now. And we're going to need to place, so we need to go back to placement. Now I could do the logic in here of resolving and placing, which I'll probably do now. Later it might make more sense to put that in a sub procedure so that it can be reused, or the functionality in it can be made more complicated without messing around in here. Sure, I'm going to do that. Let's do that. Let's create a full piece bottom. And I will resolve our. Did I keep that? Yes, I did. So that's going to be the asset. I'm going to place it. At the moment, all I'm going to do is that. The thickness is probably important, so I might steal that logic from here and put that in here. Yeah, so the X is fixed. Okay, that's our piece, which we can now use in here. So we've split off the 2 meter level into the default frame is the lower part, and the remainder is anything above, which we'll use again in a minute. So that lowest piece is going to be here. We are going to have 3 pieces, so I'm going to merge those together. Sometimes I just choose something with more inputs just in case we need to add things later. So that should be the bottom section. Let me add a new feature into here. We can try that. Where section? Okay, well, we've got a piece. Looks a bit squished, but again, that's probably because we're trying to do it to a particular size. So let's set that to 4 and 2. In fact, the height shouldn't matter because we're splitting off. Let's go with 10. I don't know how high it's going to be. That kind of looks right. It looks a little squashed. I'll work that out in a minute. Maybe it is. Maybe it's not 2 meters high. That might be a good thing to check. Oh no, it looks more like a meter. Yeah, that's probably a meter. That would fix that. So we're not going to cut off 2 meters. We're going to cut off 1. There we go. That's better. Now we've already got the logic for the next bit, which we're going to use. So if I do another split, I'll just copy that one. And this remainder above that piece, we're going to split off 2, I think, for the wall. And we can use the wall piece here, connect that up, and then we have the piece above. So we split it off into a 1 meter, a 2 meter, and then the remainder is still available. And we're going to do the same with the top. I'll just do that. Oh, welcome to the new viewers. Not sure. I'm not sure how to see all the current viewers, but apparently there's 6 of you. So hello, everyone. Feel free to introduce yourself in the chat. Right. So we need another procedure here for the top. Layer. It's largely going to be the same as the bottom, so what I might do is just copy all this, put that in there. We've got bounds, the output, except it's not going to be that, it's going to be top, and I think that'll be a meter as well. So in our section, we could just assume that the rest is top, but we won't for now, so I'll do another split of one unit, and we should be able to plug in the top. Look at that. There we go. That's a section of wall. Yeah, so these assets are quite nice. They all lock together. They have a nice exterior, which is neutral, and a really nice sci-fi kind of interior bit going on. Now we've got that, we should be able to plug it into the logic for the row instead. Hang on, where have we gone? We'll go back to the row. Instead of placing a piece, what we'll do is place a section. Drop that in there, plop that to there, and then we have a section. Move this out of the way. So those are the sections we built being applied in the row. And again, if we want more, we can excuse the motion blur. I wonder if I can turn that off. Oops, not what I wanted. Maybe it's not motion blur then. Okay, I'll ignore that. Yeah, so let's have a whole load of wall, and we what next, we ask. Let's have a look at the windows. We're halfway through, I think. That's pretty good progress. We don't need that. We're going to look next. We're going to look at a thing called variance, which is the ability in our resource list here, where we've got a piece. I'm going to take a little drink. Too much talking. Yeah, so where you've got a single asset, you can turn it into a variant, which at the moment will break how it's used, but it means we can put multiple things into a list underneath that one resource type. So at the moment we've got wall. I'll add in some more the window in a minute, but what we'll do is get this fixed first, and I'll explain what's going on there. Let's go back to the editor. So our piece here, when resources are singular, this variant input selects. It doesn't do anything, but normally you'd leave it at 0. When you've got a variant, they are listed from index 1. So the simple fix is just to say use variant 1, because now station wall refers to a list and not a singular item. There's a few things to smooth this out that you can use, but for now we'll do that. And this means it's always going to select the first one in that list. So when we put, let's go back to the resources. What we can do is go and find the window piece, which I think is this one. If I drop that on wall, we now have two things. With index item 1 is the plain wall, and item 2 is the windowed one. Now, because we're telling it to only use index 1, item 1, it will only get the wall. How do we change that? So we need some. For now, you could do things like have every other one be a different type, or we could have some other logic. But for now, I'm just going to get it to choose randomly between the wall and the window, because that introduces some other useful concepts as well to do with randomness. So we have a couple of operations here. The main one we'll need is rand range, which, as its name suggests, is going to give us a number between two values. So these are inclusive, so what we need to do is have minimum be 1, because they start at 1. And to make it automatic, we can use this this output here to select the maximum, because that will tell us how many assets have been put in that list. In our case, that'll be 2, so it's going to choose either 1 or 2 as the value at the output. So if we hook that up, nothing changes. That's because the random number generation in Apparance is always deterministic, which means it's only going to change if the input has changed. And the way that happens is your seed value has to come from somewhere. And when you've used that seed, as you can see, there's an output here which you could feed into the next operation. That means that you would get, if you put a chain of these together, you would get different random numbers because you would have different seeds passing through. It gives you much better control over how the randomness is used, and can be used in it. Has some interesting side effects which we can talk about another time that allow you to do all sorts of interesting things in making it not just random but more interestingly random, which is an important aspect of all this. So because in this procedure we're just dealing with placing down a piece of wall, we don't have any context about which piece of wall we're actually building it across along our row. So in order to get that, we need to pass in some information, and in this case it makes sense to pass the seed in. So if we give a different seed to each wall panel, it will make a different choice here and vary between the two pieces of wall. So we go back to our section here. We'll now see that we've now got a seed input here. And again, the wall section, it's a single section. It doesn't have any context to know which one of the, in our case, 4 sections we've got here. So we'll pass that seed back out another level so that when we get to our row, we can see here, so we're not doing the piece anymore. I'll remove that. So our section has a seed. Now the row is concerned about this sequence of pieces, and so it will it's the place that has the context of how far along the wall we are. And the simplest way to do that, because we're recursing, is to pass the seed into the section and then pass a different seed into the next row. In order to pass one into the row, we need to have it as a parameter on the input here, which for the current one we'll just pass straight into the section and they can use that. But for the next piece along, we want a different seed. We can't, if we pass this in, we'll just get the same effect. So there is a couple of ways of doing this. One thing we could do is wherever a random operation like this is used, we could take the new seed that it generates and pass that out, and then bubble that back up to where our through this section, again coming out here, through the row, through into the row, and then that gives us something to pass in here that is going to be the next sort of seed. There is a shortcut to that which is called the twist operator, which basically is a way of turning one seed into another seed deterministically, but it means you will get a different random number when you use it. So we're going to just do that and give us a new sequence, and we can already see, look, hey, we've got 2 windows and 2 walls. That is just the way the dice has gone. But our wall row here has this seed input at the top. If we go back out here, we now have a seed parameter here, which we can change. And as we change it, you get different results because each seed produces a different stream of random results. Let's make this a bit longer. We can see that in effect. So what this means is if you had, I mean, I can illustrate this actually. If I bring out another procedure, make a wall row. So we've got 2 pieces of wall, and if we set this one's got a seed of 46, and if we set this one to a seed of 46, we'll get the same wall. This is what is meant by determinism. So the results you get are fully determined by the inputs you give it, and each time you give it those inputs, you'll get the same results. So an example of where this might be useful is if you have 2 pieces of wall on a room and you want them to look the same, you could, in the room procedure, pass the same seed, and they would both do the same logic to generate the same choices. Assuming, for example, it's the same size and number of pieces. Okay. You've been very quiet. Any questions, please ask, and I will try and answer. What I'm going to probably look at next is what we can do to combine these into a into a room. Let's make this a bit smaller for the purposes of this. I mean, this is obviously doing it by hand, which is not the point of what we're trying to do. So we'll have a look at how I can build a room in a minute. I'm just going to take a little sip of water. Excuse me. So, as you could probably imagine, we could have a procedure for the room that takes a space. We want a room in this space, and it decides how to put the walls in, how to put the floor and the ceiling, and any other pieces needed to join it all together. And that's basically where we're going to go next. But we'll see how far we get. Because there are some subtleties, like as you can see in the corner here. When we get a corner, these pieces we'll probably need to line up something like that ish. And then we need to work out how to fill the space so all your oxygen doesn't leak out of your space station. And similarly, the floor is going to need to fill in with whatever is going on in the corner and fit nicely up to the edges, and then fill the space with interesting things. Ceiling, same. To start with, I think it's going to be, we'll just split off the four sides and make them into walls. So let's do that. Get rid of that one. This one we can move out of the way, because we're probably going to have a new procedure for the room, so we'll set that up first. In fact, I will do that now. Let's not use wall, because that's let's do room. I'll just call it main for now. A room. Funnily enough, right. Room. So, to start with, I will just put in a. Ooh, we have lightning. Sorry if you hear any crashing and banging. It's probably the lightning going on outside. Right, I'm going to start with that. Put in a new procedure, which is going to be our room. Let's make it, what did I say, 16 by 16, and just give it a height for now. So this is going to be our space we're going to fill with walls and whatnot. Let's start doing that. Oh, question. Place wall. Is it possible to place wall segments by using a loop inside a procedure rather than recursion? So at the moment, the way the evaluation works, recursion kind of fell out of it as a feature that was immediately supported. Whilst recursion is not terribly intuitive to start with, it kind of simplifies things in the long run when you're trying to do more complicated things. There isn't support for in-place loops. On our roadmap there is plans for that, but it's more of a problem to do, a user interface problem than a technical problem. So there's quite a bunch of work involved in that. So it's on the roadmap to be able to basically put down a procedure and have it be a loop or in a loop. Yeah, so that kind of, that does answer your question, but it's not at the moment. There are a few things to help, which we might cover as well, which make it a bit easier to use. I think one of the things with loops, for loops, there are a load of like simple use cases where there's most of the times you want a loop, it's really easy. You just want to go through n things, or you want to split up a number of a space into a number of pieces, or you've got a list and you want to go through every item in the list. Those are kind of a large part of why you would want a loop. But what gets trickier with loops is when you're trying to have more complicated logic about how far you're going or how many times you want to iterate. And recursion allows you to build that in one place into that procedure. So there's like 3 parts. Let me open up again. The row here. There's like 3 parts to this, where this top piece is the exit condition, and that's what you're testing each time you go around this loop. In a way, this kind of is a loop, but it just goes downwards rather than along, if you excuse the expression. So yeah, there's the exit condition here. There's the recursion itself, which is how you iterate, and what you need to change each time you go through that. And then there's the bit in the middle, which is the actual thing you're doing each time you iterate. And that helps to work out how to implement things like this. Okay. Yes, I do want to support loops of different sorts with more powerful. Just because for a lot of cases you need just the very simple. I want 6 of these or something. But it's largely a user interface and tooling challenge, which I've been working on, but haven't had the time to address. Right, where were we? Right, we've got a room, which is here. At the moment we're just showing the frame. What we're going to do is split off 4 pieces from all the way around. Is that the best way of doing it? That'll do, yeah. So what we can do for that is there's split, which takes a frame into 2 pieces, and there is a shrink which takes it into 3, but the 2 outside pieces are the same size, which for a room is probably quite adequate. What we're going to do is just chop 1 meter off both sides, and if I hook the frame up, why is that? That looks too big. Where's that? Let's put the other one in and see what that does. Right, we're going to have multiple pieces all combined together. So 4 walls, let's say, floor, ceiling eventually, maybe the corners. Don't know if we need to do them here. So that's going to be 8, 9. So I'm just going to put in a large merge, and we'll just keep bunging things into it. That's that one. What did that come out as? Ah, right, yes, sorry. So shrink, the amount you shrink is how big you want the centerpiece to be, which is why it's now there's a 1 meter gap. What you can do is you can flip it so that it's the outer amount. This is shrink by that amount. So now we've shrunk the frame by 1 meter, and we've got the 3 pieces that's generated, and that gives us some good space where we want to put walls. I will do the other 2. At the moment, I'm going to just do this twice, actually. Let's do that by doing that. Hook those up, except this time we're going to shrink in Y, and that generates those. There's going to be some problems with doing it like this, but we'll deal with those later. What we can do now, instead of drawing the frame, we could put in the wall row. For example, ta-da, there's a wall. And if we do that for this one, we can see a problem. So the 2 frames we got from the shrink, are the same orientation. They inherit their own orientation from the original frame, which means that this piece is now the wrong way around. Now there's a really handy operator for fixing that called reorient, which I will show you in a sec, which is here. And this is something that gets used a lot. for exactly this reason. So what reorient does, if I also draw the frame, let's take that as well. So we can still see the original frame. I'll disconnect these ones for the minute. So we can see here that the X is pointing forward, the Y is along the back, can't quite see it, and the Z is up. What reorient does, if I do this, we can specify an axis and a number of steps, and in this case our axis is going to be Z because we're going to spin it around vertically, and if I increase that, oh, what did I do? Oh yeah, sorry, it doesn't like, it's now sideways and then there's no room for a wall, so it didn't build anything. So if I go for 2 steps, it will have turned it fully round. It's equivalent, it's kind of like a rotation of 90-degree steps, but it keeps the same size in space of the original frame. So what we see here is it's exactly the same volume in the world, but now the axes are pointing different ways. The X is now inwards, the Y is along that way, and the Z is still up because we rotated around Z. So that's fixed our orientation problem. What we can do now is take that frame out. In fact, get rid of all those. We're going to for the same reason that we needed to flip that wall round, the other two are going to need flipping as well. So we'll take the reorient as well, but this time for this one. You can see here again, it needs to be the other way around because it wasn't enough space. And then we'll do another one which needs to go the other way. Oh, and wired up to this side. There we go. Okay, so there you go, done. Obviously we've got some overlap problems we'll need to deal with. And as you can see, they're all identical. They've got the same window patterns, which to keep things interesting, we will try and we just have them, we want them all different. So if I go back in, we can look at that. Right, so this is because they've all been fed the same seed. They're going to generate the same window wall. So what we need to do is generate 4 different seeds. Well, the first one can use whatever seed we pass in. It's the other 3 will need to be different. So again, we can use the twist to generate different random seed streams. And if I do this with a slightly different variation, it generates a different seed stream for each. Let's tidy these up a little bit. There we go. And now they should all, well, they don't have to all match. That's all be different. You never know with random. This one's got no windows. That's got 3, there's 2 and 2, but slightly different. So there we go. That's the room with some variety. Next question. What do we do next? I think we'll get these corner spaces correct. I mean, it kind of works. It's a bit of a mashed together job, but it kind of works. So we could just leave it for now. And look at the floor. Maybe we'll do that. Right. Let's save everything before we carry on. So we've got our room. So in building the room space, so these assets have different spacings at the top and the bottom. You can see here. So our floor is going to be one sort of distance in from the outside of the frame, and the ceiling is going to be a slightly different distance. But it might be useful to have to sort of try and generalize that a bit. And the floor and the ceiling are going to be very similar in the way they're constructed. There are assets for a load of ceiling pieces that are different shapes and sizes. They kind of conform to a grid. I think they're like 1 by 1, 1 by 2, 2 by 3, something like that, or 2 by 4. And then the floor has the same kind of idea. There's a few more floor pieces. I'm not 100% sure the best way to tackle this because they're different size pieces. We could start with just one and do it and build a grid, but I think what we might do is, yeah, I'll have to have a think about that. We should probably just start with a grid and see which pieces work best. I might now look at the map again. Let's have a look at the parts map. So I sorted them earlier into, we've got the wall, we've used all those wall pieces now. We've got the floor pieces are kind of flatter, obviously you want to be able to walk over them. The ceiling pieces have got a bit more artistic license, they can go all sorts of interesting shapes and features. But if we look, we've got 1 by 1, 2 by 2, 2 by 1, 4 by 1, and then there's a 4 by 2. It'd be nice to be able to accommodate those, and this has got a 4 by 4 as well. What I think might be the way to go is to look at basically randomly subdividing the space until we match one of these pieces. There's going to need to be a bit of asset wrangling to get this to work, because the procedures will need to be able to access, I need a 1 by 1 or I need a 1 by 2, and have it provide a choice of pieces for that. So we'll have to add entries in the resource list for those different types, and there can be variants in there. For example, there's two pieces here that are 2 by 1. There's 2 pieces here that are 3. There's 3 pieces here that are 4 by 1, and a couple of few 1 by 1s. So that's a good candidate for explicitly named piece, which is based on its size, and then variants for the when there is variation. So we should probably set that up and have a look at how we might divide it up. I mean, most procedural systems like this have, because it's not magic, you're having to codify some decisions about how your assets are used and how they're combined, and that's kind of led by what assets you have, what aesthetic you're going for, other things as well, like how you want to be able to parameterize it. And also you might not want a random floor, you might want it with some sort of symmetry or patterns, which again we can look at doing. But all these decisions are things you build into the procedures, and so we'll probably touch on some of that as we get onto it. So that's been an hour. What I might do is just do a simple grid using this 2 by 2 piece to show like a 2-dimensional bit of recursion or iteration to fill that space. We'll see how that goes, and then I'll probably call it a day. So let's set up that and make a few more procedures. Let's go into, so we've got wall top and bottom. I'm going to add in, let's do floor 2 by 2. Actually, what I will do is I'll create a folder in here for floor, just to keep them all together. The folders they're purely organizational, but they do change the descriptor. So here you can see the descriptor of that is now station.floor 2 by 2, which is helpful for organization. It also is useful for, you can actually you can procedurally build these descriptors. So you could, for example, switch between multiple sets of floor types, and as long as they have the same structure underneath, you would be able to reference them. So that's going to be our piece of floor, which is, oh, I didn't remember which one it was. Oh, hang on, we can find out here. This piece, floor DA, let's use that. Floor DA is there. So that's this one. Okay, let's grab that. Go back to our map. build this over here. We need a new procedure for the floor. So let's do that. We're going to do. I'm going to do it within room floor dot grid. Let's call it that. 2D floor area. Now, for this case, I'm just going to do it as a regular 2D grid. So it's a number of columns and a number of rows, and there'll be a column loop and a row loop, and then each one will then place the piece. So if I let's do floor piece. For now, this is just going to be the rectangle, the piece we were just looking at. Resolve place. Stick that there. We won't worry about the sizing. Oh, we need to worry about the thickness probably. That would be sensible. So I can take that from here again. Except the thickness is going to be in Z, so we'll do that. Okay. Oops, no. Z. There we go. We can test that by dropping in a piece here, which is now floor piece. That looks nice. Obviously, that's done as a 1x1. It'll actually be that size, which is fine. And at the moment, that's all we get because it's just a single piece. So if we do 4x4, nope, let's do bigger. Yeah, so not what we want. Let's look at dividing that up. So the grid is going to consist of rows, and then I normally name these like grid rows row piece, just as a kind of my own convention, but you can do as you need. So let's start with the row, which is going to be very similar to before. Floor pieces, and I will basically do the same thing. In fact, can I just steal some of that? I might be able to steal some bits from here. Let's do that. Yeah, I'm going to do the same thing. Let's copy that and put it in here. That's how much space we've got. We're going to be building in X and Y, so this one is going to be in X. At the moment, I'm just going to... Oh, let's do the same thing as I did before. Slightly less than the 2 meter square. Split off that 2 meters in X. Floor piece. Recursion. And okay, that's now done it in the X direction. So now we need a set of those, or rows. Which we can largely, again, steal. That we're going in Y. And Y. Units. Output. And each, instead of a piece, we're doing a whole row. So that's here. And we're going to recurse the rest. And that it might be. Let's change this to rows, and there we go. We now have a grid of floor pieces, and as we expand it, we'll get more of them. They're fixed size, completely fixed size, but it's a very modular kit. We're going to probably stick with that sort of convention. Now we could just stick it in there and go job done. But of course we want to integrate it into that procedure for the room, so we'll do that. Let's move that out of the way. Let's have a look at our room here. So we've got, for now we're not too worried about the overlap and the external, so what we'll do is we'll just drive it from the full frame here. Oh, actually I haven't done that. For reasons, I'm going to wrap rows in grid. Now the reason is that for some operations, the rows, it makes sense for this procedure to have extra inputs that you don't really need to see when you're using the grid, the floor grid. So having a wrapper around it kind of makes sense, and we now have, we'll use this as the main point to instance that the floor pieces back here. So we need one of those in here. I'm just going to hook it up to the full frame, whack it on there, and we have a floor. Now there's, as we've discussed, there's overlap issues going on here, and because it goes right to the edge, it intersects and it doesn't fit perfectly, but we can have a look at that in a minute as well. But now, as I change the size of this, we'll get more and more pieces. I might just put the ceiling on. For now I will cheat and just use another one on the ceiling. Except we need to turn it upside down, which we can do with our friend reorient. So if I take that, either in X or Y, it won't matter. Turn it around by 2, and just temporarily we get a ceiling. Ah, okay. It's based on the bounds of this, not the bounds of the actual assets. So maybe 4. Let's try 4. Looks good. So there we have version 1 of a bit of space station. Cool. I think that's enough for today. It looks pretty. I'll take a grab of that. Oops, not like that. I won't. Take a grab of that. There we go. Right. Thank you for coming. I'm going to call it a day there. Thanks, Dan. I will hopefully continue with this at some point. Maybe next week. We shall see. Keep an eye out for announcements. And please, I don't know, what do you say? Like and subscribe. I'm sure that's a thing. Do that and follow on Blue Sky and other places. Some links will come up in a minute. If I switch to the end credit scene, then you'll see all that. But yeah, thanks for coming. My first stream, seeing me build some procedural space station. Take care.